In this question we're given a circuit diagram and we're asked to calculate the compliance of the amplifier shown within that diagram. Well, the compliance of an amplifier is the limit that the output circuit places on the peak-to-peak output voltage. If the compliance of an amplifier is exceeded, clipping occurs. The AC load line of an amplifier is used to determine the amplifier's compliance. So what's an AC load line? Well, it represents all possible combinations of the AC collector current and the AC collector emitter voltage. The AC load line of an amplifier does not normally follow the plot of a DC load line. The AC and DC load lines differ because the DC load of an amplifier is different from its AC load. First, we need to determine which way we will calculate the value of the emitter current, IE. We do this by calculating the value of the DC current gain, given by HFE, by the emitter resistance, RE, and comparing it to 10 times the value of R2. The Q-point relationships assume that HFE times RE is greater than 10 times R2. If this is not the case, as in this sample question, we must consider the loading effect of the transistor when determining the value of IE. We will assume the quiescent collector current, ICQ, is approximately equal to the emitter current, IE. With this in mind, we now need to calculate the Thevenin voltage, VTH, the Thevenin resistance, RTH, and the quiescent collector current, ICQ. As shown, these are calculated using the standard formulas populated with the values given in the circuit diagram. We will assume the quiescent collector current, ICQ, is approximately equal to the emitter current, IE. Using the value calculated for ICQ, we can calculate the value for the quiescent collector emitter voltage, VCEQ. This is given by subtracting the total voltage dropped across the collector resistance, RC, and the emitter resistance, RE, from the supply voltage, VCC, or 16 volts in this question. The next step involves the calculation of the AC resistance in the collector circuit, or RC. This is given by the parallel combination of collector resistance and load resistance. With respect to the quiescent collector current, the output compliance is equal to twice the quiescent collector current multiplied by the AC resistance in the collector circuit. With respect to the quiescent collector emitter voltage, the output compliance is twice the quiescent point value of VCE. Since the former is less than the latter, the output compliance is the value calculated by 2ICQ, or C, which we calculated to be 8.86 volts.